I'm saying you didn't punch it into this, correct?
I punched it into my head.
I just took a guess.
Someone's gonna punch you in the head. All right, so let's see here.
What?
So
I did. I punched myself in the head.
So L of x,
That was
we would
me.
like to have L of 0.9. L of 0.9. So we're going to get 0.9. Our linear approximation is just x itself. So whatever you want to find, you're just going to put into that. It's going to spit out the exact same number in this case. All right.
Is that the answer?
That's our approximation, yeah.
So it's going to be.
So we found this dot up here.
0.9.
We found the 0.9, comma 0.9 dot. That's what we found on our tangent line.
How'd you figure out how to graph that? I'm still wondering
Which part? The line or the curve?
the line and
Well, the curve is just natural log of 1 plus x. So that's a horizontal shift backwards 1. When you place x with x plus 1,
yeah.
and then we knew this line was just x, right? So standard.
Yeah,
That's on your rule.
Okay.
A
A little bit of error in there. So now you're supposed to find the actual. Compute the percent error in your approximation. So what did you guys say the actual or the exact was?
had the same values for 10 years.
Justin, what number did you say it was? F of 0.9 is natural log of 1.9. What'd you get? 0.641? 0.641. Now that really is still an approximation, because that decimal goes on forever, right? It goes on forever. We got to truncate it somewhere though. So 0.641. So we have an overestimate here like we expected because it's concave down. So now how bad is the overestimate? So we'll take 0.641 minus 0.9 and divide it by 0.641 and we'll see how bad our percent error is. That's not a 1. I don't think those are 1s, right? Those are absolute value symbols. It's pretty bad this time, right? It's pretty bad error.
40%.
It's like 40 to 50%, right?
40.4%.
40.4? Pretty bad.
That's a really good estimate.
What's that?
That formula spits out really good estimates.
Well, that's why what your calculator does is it tacks on another term here. It tacks on a squared term, right? And that's going to make the approximation even better. And instead of using a line, it's going to use a quadratic function, right? So it'll give you some sort of, quadratic thing there. That's going to be even closer. And once it be closer, it's going to put on a cubic term. It's going to make it into some sort of cubic thing. Then it's going to get you even closer, and so forth and so forth.
The thing I don't understand is like, we always know the type of function we're going to use squared, cube, absolute, so you know how they look like in general. Like you have to get graph or you saw it in videos where you can't know what's going to happen.
In real life. In real life. Yeah. You won't know the expression for the function in real life. You won't know the 12 minus x squared. You'll simply know the value there. You know what the value should be at a, and you'll know what its slope is at a. But you won't have this in its derivative in terms of functions. And so then you can take the next step and you can find, well, if that's the case, then down here down the road, it's about that. I can say it's about that. And you won't have this calculation to make in the first place because you won't know the actual, right? That's the way it tends to work. Okay, so now a problem that is worded more concisely is highly related. But this time you have to pick the correct values. You have to pick the A to work the problem with. So you got to find some roots now. So another method of finding roots in 4.9 or 4.8. Right now we're using this. So let's see, we'll take the root of 146, number 15. I lied. Let's do 16. 16.
No. That's not even a word though.
We'll find the cube root of 65. Use linear approximations to estimate the following quantities. You gotta choose the value of a to produce a small error. Use L of x to approximate. Cube root of 65. And select a, meaning little a, right? Select x equals a to produce a small error. All right. So what function do you think we're going to work with?
Cube.
Sounds good. Work with the cube root function. What a value do you think we're going to work with? They didn't pick 65 on accident. It's cube root. Careful. Otherwise I would agree with you. 4. Cube root of 64 is 4. Okay? So, well, we're going to pick 64, not 4. So a equals 64. Everybody agree? Okay, so far? So we're going to let a equal 64. Is that close to 65? Yeah, I mean, it's a whole unit off, but in terms of what we're about to do is the best number possible because we know the cube root is 64. Right? It's the closest number to 65 we know the cube root of. Okay, so help me create L of x. You said that the function we're going to use, f of x, is going to be the cube root function. Now we have all the same pieces we had last time. We've got a function, and we've got a. So create L of x. Well, to get all the pieces, we need f prime. So what's the root of the cube root?
1/3 x to the negative 2/3.
Sounds good. 1/3 x to the negative 2/3.
What happened to the 65 that was under the cube radical? Why did you just switch that out for x?
Why should I for x? I want to deal with a function, not an exact. This is a value.
Uh-huh.
What function is taking in 65? The cube root function.
Okay.
That's like the function we're on.
Uh-huh.
We want to know an approximation to this, but what we know though is the cube root at 64. That's what we actually know.
Okay.
So there's where we're going to find this tangent line around, right? The tangent line at a, and we're going to use that to approximate the cube root of 65. But the function we're on is the cube root of x, ultimately. So the derivative, like you said, is 1/3 x to the negative 2/3, which is the same as 1/3 x to the 2/3. We want to know f prime at a, which means f prime at 64. And we also want to know f at 64.
Your answer is going to be really close to like 4.3.
It's going to be really close?
Yeah, like 4.4 or 4.3 because the root 65, the cube root of 65 is it's like 4 point something.
Yeah, sure.
Yeah, because it's that close. Your area is going to be like
That's what the section is about.
Yeah, should be pretty good. Okay, so f prime at 64 is what though? You put 64 into here, you take the cube root of 64, you get 4, and then you square it, you get 16. So you get 1/3 times 16.